Okay, this is section 4.4, and this is on distributions of the sample mean, and sigma, the population standard deviation, is actually known. So you know the population standard deviation, and what we'll do on these problems is we'll be using the second section of the ZNT sheet. That's this sheet right here, and we'll use this for a couple sections. So anyway, going to this first problem here. It says, assume that the cost of 2-liter bottles of Pepsi are normally distributed. The mean price is $1.16 and the standard deviation is 20 cents. A sample of 10 bottles is taken, and the first question is the distribution of the sample means normally distributed? And the answer to that question is yes, because as long as the original distribution is normally distributed, which it says here in the first sentence, it says the cost of the 2-liter bottles of Pepsi are normally distributed. So as long as the original distribution is normally distributed, then the distribution of the sample means is automatically normally distributed. So that's guaranteed right there. So yes. And then what is the standard error? Now the standard error is, there's a formula for that, and that is the standard deviation divided by the square root of your sample size. So for this problem, it would be 0.2 divided by the square root of 10. Now we could do that on a calculator, but the Excel sheet will work that out for us automatically. And then the big question is, what is the probability that the mean price for this sample of 10 bottles of Pepsi is between $1.14 and $1.17? Okay, so to do this problem again, use the second section of the ZNT sheet, and it's a betweener, see, between $1.14 and $1.17. So scroll to the right so you can put in your information. So if you want to pause the video right now, you can see that I put in $1.14 for the lower, $1.17 for the upper, $1.16 for the population mean, which was given to be $1.16, and the 20 cents right here goes in for the sigma, the population standard deviation, because we were told here that that 2-liter bottles of Pepsi have a mean price of $1.16 and a standard deviation. Well, this is a population mean, not the mean of that sample, but a population mean, and the standard deviation is also a population standard deviation of 20 cents. And the sample size of 10 bottles goes right here. Then it calculates the standard error right here. Again, that's from taking your standard deviation of 0.2, dividing it by the square root of 10. So if you do that, 0.2 divided by the square root of 10, you'll get 0.05. Then it works out the z-score using this formula right here, this z-score x bar minus mu times the square root of n over sigma, and it gets these two z-scores. Then it just gets the area between those two z-scores using an Excel sheet, and that area is the probability that a value would fall between those two. And so the answer to this problem is 0.1869, or about an 18.69% chance. Okay, going on to the second example, it says the mean height of American men is 69.2 inches with a standard deviation of 2.9. A sample of 60 men is selected. Is the distribution of sample means normally distributed? Find the standard error, and what is the probability that the sample mean height is greater than 70? Well, let's see. First of all, the distribution of the sample means is normally distributed because as long as your sample size is greater than 30, which this is a sample size of 60, then you're guaranteed that your distribution of your sample means is approximately normally distributed. So we're good with it being approximately normally distributed. Now, to get this answer, we go ahead and use the second section of the sheet again, and using the left-hand side of the sheet, put in your value that we're testing, which is 70 right here. We're going to test greater than 70, so after we get these values in, we'll be looking to the area to the right. So actually, here's the answer. We put in the mean for 69.2, and again, this is a population standard deviation of 2.9 because it's right after the population mean, so that is a population standard deviation, and they give you a sample size of 60. So the standard error is right here. Again, that's by doing the 2.9 divided by the square root of 60. That gives you the standard error of 0.374. The z-score was calculated using the formula that we used last time, this formula right here, the x bar minus mu times the square root of n over sigma. That gives you a z-score of 2.137, and the probability to the right, because it says greater than 70, that's why we use the right, is 0.016, and that would be the answer to that problem. Now here it says, is the sample mean unlikely to be greater than 70 when the sample when actually the population mean is 69.2? Well, yeah, it's unlikely. The reason is because this value right here is only 0.016 is a 1.6% chance that this could happen. So, in other words, since the probability is 1.63, and that's less than a 5% chance, and it says use a value of 5% or less, determine if it's unlikely, then we would say it's unlikely for this to happen. This could happen due to chance, or the population mean that was given is wrong, or the sample was not taken in a random manner. So I'll stop this problem right here.